In part 1, we left off with example 7, letter B, and towards the end, I didn't get to show the final answer, which is negative 1/3 cotangent 3x minus x, and then, of course, plus c. In letter C, we have the integral of cosine to the third x dx. And when we use substitution, we look for a function and its derivative in the same problem, so we can make really two substitutions. In this case, we only have one function, so somehow we're going to have to split this up so that we can have a function and its derivative in the integral. So keep in mind, this is cosine to the third. We're going to split that up into cosine squared times cosine, and then now we can manipulate cosine squared, and we can turn from the Pythagorean identity again. We can replace cosine squared with 1 minus sine squared. So we do have a function and its derivative, and in this case we're going to let u equal the sine of x, and the derivative of sine of x is cosine x. We have the function, a sine of x, and its derivative. Now I don't want to let u equal sine squared, because then the derivative would be too complicated and we wouldn't have the derivative in the integral, in the original integral. Making the substitution, we have 1 minus u squared. Sine is u, replace the sine squared with u, get u squared. And cosine dx is going to be replaced with du. The antiderivative of 1 is u. Antiderivative of u squared is 1/3 u to the third. We have plus c. Didn't start with u's, can't end with u's. So we have sine x minus 1/3 sine to the third x plus c. And that is example 7. Next is example 8. It's now a definite integral. We're going to integrate from 0 to pi over 3 of tangent x secant squared x dx. In integration by substitution, we're looking for a function and its derivative. In this case, the function is tangent, and the derivative is secant squared. So we're going to let u equal tangent of x. When we take the derivative of both sides, we get du equals secant squared of x dx. Now we're integrating from 0 to pi over 3. When we make the substitution, we just get u when we substitute that in for u in for tangent of x. And this whole secant squared dx gets replaced with just du. Now we have 1/2 u squared. That's the antiderivative. Well, instead of putting tangent back into the u, I can put pi over 3 in for the tangent of x, and the tangent of pi over 3 is the square root of 3. And we can put 0 in for tangent of x, and the tangent of 0 is 0. So instead of putting tangent back in, we can change what we're integrating from. Now we're integrating from 0 to the square root of 3. To evaluate this, we put square root of 3 in for u, we put 0 in for u, and our final answer is 3/2. Oh, and there's where I showed how you can change what you're integrating from. Instead of 0 to pi over 3, if you plug pi over 3 in for tangent and 0 in for tangent, you get the new interval that we're integrating over. In example 9, it says that absolute value again. Well, that comes from the antiderivative of 1 over x is a natural log of absolute value of x. In this particular case, we do have a function and its derivative. The function is x squared minus 4, and the derivative of x squared minus 4 is 2x. Now, we don't have all of the derivative. We don't have the 2x, but we have the x dx. So to make that replacement, we can just divide by 2. And now we do have the x dx, and it's going to get replaced with 1/2 du. When we make all the substitutions that we need, the 1/2 is on the outside, du is over here. So x dx is replaced with 1/2 du, and the x squared minus 4 gets replaced with the u. So we have 1 over u. The antiderivative of 1 over u is a natural log of the absolute value of u, and the 1/2 just kind of tags along. Well, instead of plugging x squared minus 4 back in, we can just change what we're integrating over by plugging 1 into x squared minus 4, like I've done here. And now the top, instead of being a 1, is a -3. And we can plug 0 into x squared minus 4 into the u, and we get -4. So now we're integrating from -4 to -3. So to evaluate the antiderivative, we plug -3 in to u. Absolute value of that would be 3. minus, plug the 4 in, becomes 4. And then one of the properties we have for logs is I can factor out the 1/2 and turn the natural log of 3 minus natural log of 4 into the natural log of 3/4, and that's probably as far as I would take that.